Okay, cool. Just making sure this is working. Perfect. So right now, um, our next test is going to be on Friday. We're going over angles and trig functions. So I'm going to go ahead and just start off going over the Unit 2 review. So I'll just pick a question from each section and I'll go over it on all of this. So um, for the first one, I'm actually going to pick two. Determine the quadrant in which the terminal side of the angle lies. We'll go ahead and look at number one. Um, one, looking at 282 degrees. So for this one, uh, it's a little bit simple. I shouldn't be saying that, but oh well. Always draw your unit circle like this because it's a positive. We're going to be going this way. So 282 degrees. I know that one of my quadrantal angles is going to be 270 plus um, another 12 from the 282 because well 270 plus 12 is 282. So you're going to end up somewhere uh, about right there, meaning that you are going to end up in quadrant 4. For number 2, we have 5 pi over 7. Again, I'm going to draw our unit circle here, or our graph here. 5 pi over 7, we know that 1 pi is 180. So it's not quite 180 since this does not equal pi. So what I like to do with this is um, divide pi or 180 by 7. Um, Let me just grab my graphing calculator real quick so I can do all this. Um, I'll give very explicit instructions on how to do this. So 180 or pi, make sure to put 180 into the graphing calculator. 180 divided by 7. Okay, so 25.7. Sure. We'll just we'll do 25.7. 25.7 times 5. We get um it's about 128.5 degrees. So um this isn't quite 180 as we said before. Um or another way that we can look at it actually, this is a lot simpler. This is going to be more um if we were to split this up into 7 sections, this is going to be more than half of it. So we know that it's going to end up in quadrant 2. So for this one, I'm just going to draw a line like right there. So I know that's going to be quadrant 2. Okay. Go ahead and create a new one. Next up, sketch the angle in standard position. I'm just going to take the first one, number 5, and that is negative 2 pi over 7. All right, negative 2 pi over 7. Just going to draw our graph there. That'll have to do. Negative 2 pi over 7. Again, this isn't quite 180. And if it makes a little bit more sense to think of it in degrees, then we can convert it into degrees real quick. Um, the formula for this is going to be x radians um, multiplied by um, 180 over pi. So this is going to equal negative 2 pi over 7 times 180 over pi. That's really just going to equal, or I guess, yeah, we can just multiply it from here. So on your graphing calculator, negative 2 pi over, wait a minute. Nope, I'm wrong. Um, we're basically just going to cross out a pi from here. So we're just going to get negative pi times 180 over 7, I believe. Um, so that is pi, ah, pi times 180 over 7. Going to get about negative 80.7 degrees. If that's easier to think in, then convert it to degrees by using this formula here. So now that we have that, um, we know that is going to be somewhere around, we know it's not going to be clearing the 90-degree mark right here. So let's just say it's about right there. And there we go. That's it. Okay. Next section, state the reference angle for each of the following angles. Answer should be in the same unit of measure as the problem. Um, this one is a little bit interesting. Um, there's a way that Mr. Froberg taught us in class that I don't really like doing it that way. Um, I'm going to go ahead and do two of these. I'm going to do number 7 and number 8. For 7, we have 237 degrees, and we need to find the reference angle of this. I'm just going to create that real quick. So 237 degrees, um, that's going to be somewhere along here. Um, so because this takes a little bit of practice to, I guess, understand. However, all you're really doing is trying to figure out what you need to do to take this angle and bring it up to here, and what angle this is. So we'll just call this theta. So we know that this right here is going to be either 0 or 360 degrees, of course, or um, 0, 0 pi, or um, 2 pi. Over here, it is always going to be pi, or something pi. It can be 3 pi, it can be 5 pi, it can be 7 pi. It can never be an even number. If it's an even number, it is going to be over here. And this is also equivalent to 180 degrees. So what do we need? What angle do we need to take 237 degrees to 180 degrees? Very simple. Just subtract 237 minus 180. Um, so you're going to get, what is that, 57 degrees? There's your reference angle. The reference angle for theta is equal to 57 degrees. Again, you are just trying to figure out what angle you need to take to get to here. Let's go ahead and do another one. We'll do the one with, let's go ahead and do number 8. Um, so 8 is 2 pi over 3. Again, we will draw our unit circle here. Again, we know that this is going to be pi, and this is either going to be 0 or 2 pi. Just keep that 0. You don't need to put the pi in front of that. So 0 or 2 pi over here. We know that this is 180. This is really close to just being pi, but it doesn't equal pi just yet. What we need to do um, is I'm just going to estimate here, since that's about 60 or that's about 120 degrees. Um, it's going to end up right around right here. Um, 2 pi over 3. Because of that, I need to know what angle in radians I need to take to get to pi. Um, Now again, this is kind of simple. You can just take pi and subtract 2 pi over 3, and you'll get 1 pi um, over 3, I believe. Yeah, you'll just get pi over 3. Um, because 2 pi over 3 plus pi over 3 gives you pi, because the 3's cancel out. Making sense so far? I sure hope so. If not, please ask me any more questions that you have. Oh boy, okay. I'm gonna need to drink some water here soon. Anyways, next up, um, we'll go ahead and look at 10. Name one positive and one negative coterminal angle for each angle below. Answer should be in the same unit of measure as the problem. This one is really simple. 10, 7 pi over 12. Um, Multiply this by 2 pi. Or wait, no, not multiply. Add 2 pi. Something that I really like to do is just take 12 multiplied to 2, and you get 24 pi over 12. Um, and that's pretty easy to do. And then just subtract, or then just add 7 pi over 12, and you'll get, what is that? 17 pi over, nope, not 17 pi. Oopsie daisy. Um, 31 pi over 12, and that can't be simplified. And then same thing, 7 pi over 12 minus, this time subtracting to get a negative coterminal angle. Subtracting 24 pi over 12, and that is going to give you um, negative 17 pi over 12, I believe. But that's really it for 10. Same thing with 11, except you're just subtracting 360. Let's go ahead and create a new document here. And then are the following angles coterminal? This one is pretty easy to do. We'll just take 12, for example, 61 pi over 36, and then negative 83 pi over 36. All you need to do for this, again, um, either subtract or add 72 pi over 36. How did I get that? 36 times 272 pi over 36. um, if it makes a little bit more sense, um, think of it as 2 pi over 1. What do you need to multiply this side by to get the same denominator? You just need to multiply by 36. So 36, 72 pi, and that's really it. So once you do that, you can just do, if you want to do it on the calculator, it's just going to be 83, negative 83 over 36 plus 72 over 36. And that is going to give you 6 plus 72 over 36. That's going to give you negative 11 over 36. Um, Now we haven't gotten to the coterminal angle just yet, so we are going to add another 72 over 36 because that's another 360 or 2 pi. Um, that is going to equal 72 over 36. That is going to equal 61 pi over 36. So yes, they are coterminal. And then same thing for number 13, except with 360. Uh, Next is converting each of the following degree measures into radians. Show your work. This is number 14 and number 15. Same formula. If you want to, or if you want to convert it into radians, you're going to take x degrees multiplied by pi over 180. This, since we are going to be doing 14, it's going to be 485, 485 degrees. Make that better. 485 degrees. Um, so 485 times pi over 180. What I'm going to do is just 485 over 180 in parentheses, take pi out. This is going to give you 35 over 180, 97 over 36, so 97 pi over 36. Another way that I used to do it, if you guys want to do it this way, subtract 360 from here. You're gonna get 45 minus 360. 25. Uh, Never mind. It's kind of a stupid way to do it. Just follow this. Um, just follow this formula for degrees to radians, and you'll get it exactly like this. Okay. Next one. Convert each of the following radian measures into degrees. Show your work. For this one, it is going to be x radians um, multiplied by 180 over pi. We're going to go ahead and do number 16. 17 pi over 12. You can take 17 pi over 12 times 180 over pi. Um, let's see. Oh, geez. My mind is blanking on this. I don't really like to do it this way. I'm gonna be honest. Because I don't know. I don't like using this because you get this and I don't exactly know what to do with it. I like thinking of pi as equal to 180. So 17 times 180 over 12. Uh, Divide 180 by 12. You're going to get 17 times um, 1 8 or 17 times 15. Multiply that. Multiply these two together, you get 255 degrees. Um, it's a heck of a lot easier than having to deal with this. I'm sure if you just plug this straight into the calculator right away, let me go ahead and do that real quick. Pi over 12 times 180 over pi. Yeah, you get the same thing. Just plug this into the calculator and you get 255 degrees. What time is it? Oh, geez. Anyways, let's see. Now we're getting into the 45, 45, 90 triangles and the 30, 60, 90 triangles. These ones are a little bit more confusing. I still need to study these a little bit. But let's see. Let's go ahead and take two of them. We'll look at um, hmm, oh wow, I am blanking on these. Sorry, I'm a little bit tired. Let's go ahead and take a look at 18. I'm just going to draw it in a triangle that I can comprehend. Is that I know that this is going to be 45 degrees. M is our hypotenuse, and is that one of the sides is 7 root 2 over 2. N is going to equal, since it's the same as this side, 7, 7 root 2 over 2. Let me get my notes out of here real quick. Um, hmm. Give me just a second. I think it might be 2x. I'm not entirely confident with that. Yeah, okay. So it's just the Pythagoras theorem. Get x squared plus x squared is equal to d squared, and yada yada yada. You somehow end up with x square root 2 is equal to d. I believe that's how that works. Yikes. I'm not doing too hot with this subject right now. I apologize. Why is it not coming to mind? Um, Shoot. Hmm, This is fine. I'm way too tired to be doing this right now. Um, but it should just be, I guess it wouldn't be that. Um, just a second. Gotta check Mr. Froberg's notes on this. I understood it, but then I didn't. And that's not good because this test is on Friday and prob I'm not gonna fail it. But geez. Okay. I figured it out. So it is just gonna be x times root 2. So our n's are our x's, m is our d. Uh, so you're just gonna get 7 root 2 over 2 multiplied by root 2, meaning m is going to equal, just go ahead and plug this into the calculator. Um, 7 times root 2 over 2 multiplied by root 2 is just going to equal 7. That kind of makes sense because, yeah, okay, that makes sense. But anyways, there are your 2 answers. Sorry, that took a little bit too long. Um, let's go ahead and do a 30, 60, 90 triangle. We'll take 20. We have this. That's not good. There we go. There's our 90. This is going to be 60 degrees. This is our m. This is our n. And this is 10. So our short leg here, um, or let's go ahead and start off with 10. The hypotenuse is going to equal 2x, meaning n. Okay, my headphones decided to just power off there. Anyways, um, n is just going to be 1 of x. Our hypotenuse is equal to 2x. So n is equal to 5. Now our m is equal to um, x cube root 3. This x here is just going to equal 5. So our m is 5 cube root 3. That's as much as that we can do with that. So there's your answer for that. Um, and I think that might be, yeah, that's about all that we can do on the review for now. Everything else I will go over later. For now, I'm going to give you one more thing that's going to help you a lot in these coming few um, and I believe is going to be our last section. It's going to be a little bit confusing, but this table here, sine, cosine, tangent, um, 0 degrees, 30 degrees, 90, whoops, 45 degrees, 60 degrees, and 90 degrees. Okay. Um, Sine of 0 is just 0. Sine of 30 degrees is 1 over 2. Sine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. And sine of 90 is equal to 1. The cosine of 0, or everything else on cosine, is just the exact same, or is the same but opposite. So 0 is 1, 30 degrees is root 3 over 2, 45 is always root 2 over 2, then 60 degrees is 1 over 2, and then it is 0. And then finally for tangent, tangent is a little bit more weird about it. Um, it's going to go, I believe, 0, 1 over 3. Whoa, hold on, I did that wrong. Um, because there is no 0 for it. I think it goes 1 over 3. Oh, geez. Give me just a second. So, is that right? Yeah, okay, I was right. It is 0, 1 over root, or root 3 over 3, 1, root 3. Yeah, okay. So, what the heck? I have no clue where that came from. I don't want that. I don't want that. Hold on. There we go. Okay, so it is going to be 0, um, gosh dang it. No. Root 3 over 3, 1, um, root 3, and then undefined. 1 over 2, 0. There we go. If you know this table and you see or you recognize any of these reference angles, the rest of them should come pretty easy for the last few or for the last unit that we go through, the last section that we go through. Um, if you need this to be a little bit neater, then it is just going to be angles table, not angles table full angle. Gosh dang it. Here we go. Um, this one here, I guess. Uh, that we don't actually want. let's get something a little bit simpler. Here we go. This is what I was trying to draw out. Again, it goes 0, 1 over 2. This is supposed to be root 2 over 2 because you cannot have a radical in the denominator. Then root 3 over 2, then 1, then 1, root 3 over 2, 1 over root 2 over 2, 1 over 2, 0, then 0, root 3 over 3, 1, root 3, and then not defined or undefined. Anyways, that's all I got for now. Sorry that this video went kind of long. Have fun!